All right, in this section, we're going to start talking about the 4 steps of the hypothesis test. Again, just in generics, just what we're trying to do and how we're going to do it. Before we get into those, just a note, this is for the 2-tailed version. Just like last chapter, there's a 2-tailed test and there's a 1-tailed test. Just like last time as well, 2 tails just means we're predicting that there will be a difference as a result of the treatment, but we're not predicting if scores are going to go up or down. When we do the 1-tailed version, that's when we'll be specific as usual about scores going up or down. But right now we're looking for 2 tails. It could go either way. We got to look in both sides of the curve. So starting with step 1, we're going to find that step 1 is literally 100% identical to the last chapter. There's no changes in step 1 for us in this chapter. There will be in other chapters, but this one is the same. So we're going to report both hypotheses just like usual. We're going to say that the alternate hypothesis is the treated population mean will no longer equal whatever number the starting value was, whatever the untreated population was. Again, we've got to get that out of the story problems or we don't have a number to put there. And exactly like last time, we're going to report that the null hypothesis is the treated population mean will still equal whatever number the starting value was. So this is, again, 100% exactly like last chapter. There is absolutely no change. When you're doing this for your quizzes, and maybe exams, hopefully we'll be back live before we get to exams, remember you can either use the symbols, but be careful. Some of you are missing symbols when you're trying to put symbols in there, or you can just write it in English as we speak it. The alternate hypothesis is the treated population mean will not equal whatever value. The null hypothesis is the treated population mean will equal whatever value. So you can put it in English, you can put it in symbols, whatever works best for you, whatever's most expedient and easiest for you. That's what I want you to go ahead and do. So that step's pretty quick because there are literally no differences there. In our next step, we'll find a couple of small changes. So in step 2, we are doing what we always do. We are using an alpha level to determine now what's called a critical T instead of Z's to figure out how different is different enough. How far out in the tails does our sample have to move in order for us to be convinced that the treatment caused those differences and not just random chance. So as usual, we have 2 alpha levels to work with. We have a 0.05 and we have a 0.01. Those will be the same 2 values, but we're going to end up using a different table that we'll take a look at in just a moment. The reason why the table has to change is, remember what I said in the introduction. The main difference, the fundamental difference between a T statistic and a Z statistic is that we're going to use the sample variance to replace the population variance because we don't know it. Well, let's think about what that means to us then. Sample, we're using the variance coming from a sample. We know from our mantras that sample size makes a difference. We know that the bigger a sample gets, the less error that sample is going to have in it as it represents the population. The smaller that sample is, the more error it will have. Well, since we're using the variance from the sample, and sample variance depends on sample size. Remember computing that. We'll take a look at that again in step 3, but it's sums of squares divided by degrees of freedom or sample size minus 1. Sample size is going to have an impact on this step. It literally is going to change the shape of the curve. So what we're going to find is as the sample sizes go down, and we're bringing more error into the system, it's going to distort this normal curve. What it's going to do is it's going to stretch it out. And as it stretches it out, it's also going to flatten it. So almost like the coronavirus flatten the curve graphics, I'm sure most of you have seen by now. As we widen the curve out, it also gets flatter. So as the sample sizes are smaller, the distribution will get wider and flatter. We call it a T distribution now because we're using T scores. But that's an important characteristic. So think about that. If the curve is getting wider, it's moving those critical regions further and further away from the center. So that's why we have to take into account the size of the sample when we're trying to figure out where those critical regions are. Where are these targets? They're going to move based on sample size, in essence. So what we need is our new tables, and I know you're probably not going to be able to see this on the camera, but you can look at it in your own books, of course. This is table B.2 on page 537. This is our t-distribution table. And it tells us every value we're going to need to know for this chapter. So it's a one-page table. It makes life much easier for us. So looking at this table carefully, and I'm going to try to, let's see if I can tell where the heck I am in this. Yeah, you're never going to be able to see that on camera, I don't think. But if we look at this carefully, across the top, it tells us if we're wanting to look for a proportion in one tail, that's the row at the top, or the proportion in two tails. Well, we're doing a two-tailed test, so we're going to use the two-tailed row. When we do the one-tailed test in a minute, we'll be using the one-tailed row. So one of the nice things about this table is you do not have to worry about cutting your alpha level in half manually. The table is going to do it for you automatically. That's why it has the two different headings on it. And we can see a number of alpha levels: 0.50, 0.20, 0.10, 0.05, which is of course one of the ones we're going to want, 0.2 and 0.1. For the two tails, we're going to want these the last column and second to last or third to last columns right there. Now, one of the things as you're looking at this at home that you'll notice is we've got a new element involved in here. Coming down the far left-hand side is something we haven't talked about in a while: degrees of freedom. Remember that degrees of freedom is your sample size minus 1. So this is where we're taking into account that sample size. We're really using degrees of freedom, but we're taking into account sample size. So you have to know your sample size minus 1 to use this table. And this is why you won't be able to memorize this particular table, because every problem is going to have a different sample size, and you wouldn't want to try to memorize all of that. So we're going to look for our degrees of freedom, and then we're going to slide over for to two tails or one tail, slide over to the correct alpha level, and see what we've got. So, for example, if our study had, let's say, 20 people in it, we have a sample size of 20. And we're doing a two-tailed test. And our alpha level was, say, 0.05. What we're going to find here, give me something to hold my place. If the sample size is 20, our degrees of freedom is 19. So we're going to slide down this chart till we see 19 degrees of freedom. This is awkward. 19 degrees of freedom. And then we're going to slide over, using the two-tailed row, over to 0.05 and go down. And we're going to see that our value is 2.093. We're going to use that value just like we would in any other hypothesis test that we've already run. That this is going to tell us that our t statistic is going to have to either be above 2.093 or below negative 2.093. Either way, it's the same purpose. So as we continue to look at this, let's say we have a sample size of 50. Well, if we had a sample size of 50, our degrees of freedom would be 49. Let's look at the table and we see, lo and behold, there is no 49 there. So we follow the same procedures as we've always talked about. If the number you're looking for isn't there, ask yourself, Is there a value that's closest to the one I'm looking for? Well, if we're looking for 49, our choices are 40 or 60. 40 is the closest one. So we would use the 40 line. And so at 40 degrees of freedom, slide over on our sheet. Again, if we were doing two tails at 0.05, we would see that's a 2.021. And now my cat has said hello to you. If we had 51 people in our sample size, just bump it up by 1, if we had an N of 51, our degrees of freedom would be 50. And again, our 50 isn't in there. So our question remains the same. If the number you're looking for isn't there, look for what's closest. Well, there is no closest. 40 and 60 are equidistant. It's a tie. So we look at the critical z. Which of those values is going to give us the larger value? Or I said z, didn't I? Which one is going to give us our larger value for a critical t? Well, between 40 and 60 at 0.05, again, 40 is 2.021 and 60 is 2.000 exactly. So which one's the larger value? 2.201. So if we had 50 degrees of freedom, we would still use the 40 line. Now, one last thing here. Let's look all the way down at the bottom and notice it says infinity degrees of freedom. Of course, that's not realistically possible. But as the sample size gets larger, there's less error. As there's less error, the curve gets less distorted. It gets less pulled out. It gets less flattened. So as the sample size gets big enough, it starts to shrink back to the proportions it's supposed to have. It goes back to being a little skinnier and taller. And if we look here, at 0.05 for two tails, at the very bottom row, it's 1.960. That's 1.96 from the last chapter. So we can see that as the sample size gets bigger, the curve starts to narrow up and get as tall as it is supposed to be. So also, let me note, I didn't say this table is to 3 places. We mentioned that once before briefly. 3 places. So leave the table alone. If the table's in 3 places, we write our stuff in 3 places. We don't try to alter that at all. All right. So also take a look at, I'm going to scooch this way. Hi. Hi. I know. It's nice to see you. On page 241, figure 9.1 just shows you it's got 3 normal curves essentially. So the z-statistic curve, the z distribution isn't perfectly normal, but it's still bell-shaped. And it just gives you a graphic way of looking at, well, what does it look like if there's 5 degrees of freedom, if it's 20 degrees of freedom, or if it's truly a normal distribution. And you can see as the degrees of freedom get smaller, which means that the sample sizes have gotten smaller, that the curve gets flatter. It's not really showing you it getting more spread out, unfortunately. It should show you that as well. But it shows you that as sample size goes down, it gets flatter. So it's just a little graphic to look at there to help you with that. So those are the first 2 steps of a t test for this chapter, for a single sample t. So step 1 is identical. Step 2 is really similar, just a couple of little changes. But the end result is we get a critical t value that defines our critical regions, and we use it the same way. All right, so we're going to continue on with steps 3 and 4 on the next video.